This conference will now be recorded.
Hi, good morning. In today's session, we're going to discuss about what is meant by change data capture using Snowflake dynamic tables. Okay, before going into this use case, I'll want to give you a glimpse what is mean by dynamic tables. Okay, how we can able to build one pipeline using dynamic tables. I want to give you an overview. After completing the overview, then I'll come to the use case, how we can able to perform the cdc nothing but change data capture. It's one of the important topic in etl. Okay, now before coming to the use case, I will discuss some introduction about the dynamic tables. Before that, I want to discuss what is meant by continuous data loading. Okay, now for example, most of the etl things, how it works, right? First, the raw data is loaded temporarily in a staging table. That is the L1 layer. The it can be a files. Okay, from the files or from any database tables, you will extract the data and put into a one interim storage. Interim means a temporary storage. Okay, that is called staging table. That's called a L1 layer. Whenever the raw data appears, right, it's a file or anything. It can be any APIs or it can be database tables. You have to extract the data and put into the staging layer. That is nothing but L1 layer. Staging layer is nothing but interim stages, interim storage. It's a temporary storage, I can able to say. Okay, good. Now, once the data comes into the staging layer, what I will do some transformation. After doing some transformation, I will put in another table. Okay, like this, I will keep on doing transformations one by one and put into the various tables, table by tables. I will put. Okay, and finally the entire tables I have, right, after transformation, I will write some SQL queries and then I'll create a reporting tables. That's going to be a destination table for you. Okay, it looks like somewhat like you are taking the data from the raw layer and putting the staging layer. From staging layer, doing all kind of transformations, and finally what happens, right, you are doing some transformation, putting another table. After transformation, putting another table, like this, putting various tables, and finally you are creating the reporting table. That's going to destination table for you. This is how the data pipeline will works. ETL data pipeline will works. L1 layer is nothing but raw layer to staging. L2 layer is nothing but raw layer to transformation layer. That is nothing L2. L3 layer is nothing but from the transformation you will do all kind of joins, and then you will create some dimension tables, fact tables. Finally, you will create a reporting tables. That is nothing but L3. That is nothing but L3. Now, what is L2 layer? What is L2 layer? I'm
Transformation.
asking, it's a transformation layer. What's the L3 layer? What's the L3 layer? From the transformation layer, you'll get a various dimension tables and fact tables. From the dimension tables, you will derive one reporting table. Okay, that's going to destination table for you. That is nothing but a L3. Now, this L1 layer, L2 layer, L3 layer we have, right? We will build on data pipelines. Automatically, data will be extracted from the raw layer and then come to the staging. From staging, we will do the transformation and put into another table. From transformation layer, we'll create dimension tables, and finally, reporting tables will be generated. That is nothing but their destination tables. This is how the data pipeline will works. Okay, for this data pipeline, what happens, right? There will be a continuous data load will happen in the source table. Source table means I can say it's a staging table. continuous data load will happen. Now for continuous data loading, what I did, right, I used Snowpipe. Whenever the data comes into the external stage, from the external stage, the data will be loaded into the Snowflake table. Snowflake table. It can be a external table or not external table. It can be a physical table. Okay, the data loaded into the physical table. This is nothing but a continuous data loading. Once the data comes as a batch in the external stage, we'll try to load it into the Snowflake tables, and then we can use Snowpipe streaming. Okay, this is another API. Using streaming, what we can do, right? We can able to load the record by record into the Snowflake tables. We have one Snowpipe streaming API. What it will do, right? It will read the record one by one from the file, and then it will load the data record by record into the table. Okay, these are nothing but a continuous data loading. Now it's just to load the data. Guys, I'm saying to you, it just what it will do. Once the data comes to the external stage, it will just load the data. But today I'm going to see about continuous data transformation. Continuous data transformation means once the data comes into the staging table, or we can say the source table, once the data comes into source table, automatically transformation also should occur. That is nothing but continuous data transformation. Guys, clear? Once the data comes into the source table, like after 5 seconds or some 10 seconds or 10 minutes, some lag should be there. After 10 seconds, continuous data transformation should appear. What I'm saying, Sadesh, once the data comes into source table, in the after some 10 seconds or 15 seconds lag, what should happen?
Data transformation.
Data transformation should happen. That's why I mentioned is continuous data transformation. Okay, the continuous data transformation you can achieve in two ways. One is using dynamic tables. Once the data comes into the source table, what happens, right? The dynamic tables will do all kind of data transformations. See, in a data, if we change any one point also, it's a transformation. Okay, we can say the filter transformation, just joints transformation, or group by transformation, all kind of transformation you can use, and you can able to change the data as per your requirements. Now our focus for the next 1 week is
Continuous data transformation.
continuous data transformation. Okay, you can put in a resume like I am did in the continuous data transformation using dynamic tables. Okay, in the last session we have seen the continuous data loading using Snowpipe. Okay, the remaining things are streaming. We'll covering it later. Snowpipe streaming and Snowpipe Canatra for Kafka. It's one of the streaming tool. Using Kafka also you can able to do the continuous data loading. But today for agenda is Sandamal. What's the today agenda? Today agenda is Anand.
The
Today agenda is
continuous data transformation.
continuous data transformation. Once the data comes into the source table within some lag, after some lag, what you should do? You should do the continuous data transformation. For continuous data transformation, what I'm going to use? I'm going to use
Dynamic tables.
Dynamic
dynamic
table.
tables. Dynamic tables. Sendamal, I'm going to use dynamic tables. Okay. Yeah. Now, you might have a question. Can I use dynamic tables to create a pipeline? Yeah, you can able to create some sequence of pipelines using dynamic tables. I will say it later. Okay, but you can able to do, and then it's one of the simplest way to transform data using dynamic tables. And then most of the ETL task, how it works, right? They'll put it right at the staging layer, and then they'll write some SQL queries. After doing some transformation, they'll put in another table, and then There also they'll write SQL queries. They will do some transformation. They put into another table, and then there also they will write some SQL queries, and then move into another table. Like this, they will move into table by tables. They will do. Okay, after applying one transformation, they will move to another table. After applying another transformation, they move to another table. Like this series of tasks in normal ETL process they will follow. But using dynamic tables, right? What it can do, you can simply define the end state of transformation. Ninga, for example, I can say in the final transformation, what you're looking for, you can achieve in a single step, or you can have some series of steps, series of dynamic tables, and then you can able to achieve it. You can have dynamic table 1 and dynamic table 2. Like this, you can able to achieve it. That is nothing but a continuous data transformation, guys. Now see, next one is change data tracking. For change data tracking means, in the source table, if there is any change in the data, any insert operation or update operation or delete operation appears, what happened, right? We're going to use Snowflake streams. Stream is one of the Snowflake object. What will happen, right? It will look for the changes, which data got changed based on my DML operation. It can be insert, or it can be update, it can be delete. Okay, if anything changes based on the DML, it will track those changes, and then it will extract the delta of that record. Okay, that's what the stream object will do. Satish, what stream object will do? If you are performing any DML operations on the source table, it will look at the changes, what happens. Okay, it will take the delta part alone. What are the changes happened, right? It will take the delta part alone. That is nothing but the change data capture. Guys, I want to make it clear again. Change data capture means, in the source table, after performing some DML, insert, update, or delete, the data will get changed, right? After new record will come, some update means some existing records will be updated. That records alone will be captured as a delta. Okay, that is nothing but change data capture. We'll extract that records alone and put into a target table. Guys, clear?
Yes, sir.
CDC, it's clear for you. It's very, very important topic in ETL. Okay, change the capture. In a source table, if any DML operation appears, right, like insert, update, delete, that part of delta will be extracted and put into the some target table. Okay, that is nothing but what's the concept name?
Sir, change data capture.
CDC. You have to say CDC, change data capture. We are capturing the delta and putting into the target table. Okay, that is nothing but change data tracking. We're going to see it later. Okay, like streams, we're going to see it later. For change the data, right? Whichever data got changed, that data we're going to track and going to put into the target table. That thing we're going to see it later. Okay, the last one is recurring task. Recurring task means, in Snowflake we have one object called task object. Task object, we can schedule the task, and then you can execute your SQL statements. Sendamal, task is one of the object. You can set some cron tab pattern at a particular time, that SQL query will be executed. Got it? Now, I'm giving one scenario for Sendamal. Sendamal, you have one store procedures. You have one store procedures. 5 BST timings, you have to trigger the store procedures. Now, you'll go for dynamic tables or stream objects or tasks. Which one you'll go for? You have to
Task,
trigger 5 p.m. BST. Which one you'll go for?
task.
Which one? Task object. Make it mute. The task object nothing but, if you schedule some time, right, at a particular time, what will happen? It's going to trigger your store procedures, or can be executed SQL statements. You can able to execute SQL statements. You can call the store procedures. Okay, you can do that. Is nothing but a task. We're going to see it later part, but I'm giving you somewhat glimpse on this task as of now. Tasks can be chained together. Okay, chained together means if one task executed, then next task will trigger. Second task executed, third task will trigger. Third task executed, fourth task will trigger. Now the task will going to have a chain. This is clear. Task are going to create a
Yes.
chain. If task 1 completed, task 2 will trigger. Task 2 completed, task 3 will trigger. Task 3 completed, task 4 will trigger. What the task will do? What the individual task will do? What's the individual task will do? I'm asking. Guys, I'm asking you what's the individual task will do. It used to execute here. It used to execute here SQL statement on a recurring schedule. On a schedule basis, it's going to execute.
This conference will now be recorded.
Guys, like I can say like task you can make a chain. Okay, like you can get multiple tasks, one task completed, another task will be executed. Like this you can make more complex periodic processing. Like for example, if I have 200 SQL queries, first SQL query I have to execute, after that second SQL query I have to execute. Now Satish will say how many tasks I have to create for 200 SQL queries. For 200 SQL queries, one SQL query should get executed. After that, second SQL query should execute it because one query is dependent on another query. Okay, or we can say it's one transformation dependent on another transformation. Now, how many tasks you going to create?
Sir,
Satish,
200.
200 tasks you have to create. That's you have to create a chained. Should be a chain or combination. Okay, one task completed, another task should trigger. Okay, now these are the various things I can say. Okay, these are various features we have in the continuous data pipelines. See, in interview you can say I work on continuous data pipelines. Okay, I work on continuous data loading. I work on continuous data transformation. I work on change data tracking. I work on the recurring task as well. Okay, you have to explain to the peoples like I worked with the continuous data pipelines by using all these features. Data loading I know, continuous data transformation I know, change data tracking I know, recurring task also I know. Okay, now my focus is next one is I just given a overview to you guys. Now I going to do the continuous data transformation using dynamic tables. Okay, now I'm going to discuss few things about dynamic tables. Just dynamic tables, it's very one of the important feature in the continuous data transformation. It provides error free. Error free means reliable. Reliable error meaning is error free and cost effective, automated way to transform data. There won't be any intervention. Okay, no need of any human intervention. Automatically you can able to transform the data. Once the data comes into the source table or staging table, automatically it will take those data and will do the transformations. Okay, no need to worry about it. Okay, it will do the CDC, it will do the change data capture, and then will apply the transformation. And then most of the edit process said right, they will follow some various steps like ingestion into the staging table, and then they will do transformation, and they will get dimension tables, fact tables, and then finally they will load the results in the target table. All this sequence of steps you can able to handle in the dynamic tables. Dynamic tables majorly used for transformation. And then what we can do is, if we are using streams, right, streams will extract the CDC. Okay, it will take the change data capture, whatever the data got changed, it will capture the data, and then we have to use some task to schedule your transformations. If you are using streams, definitely you should use task. Sendamal, if you are using streams, it will extract the data using CDC. Only delta records will get extracted, but for running transformation, you have to use task. Now, I want to discuss with you guys two things. I'm going to perform CDC. CDC can be achieved through dynamic tables. Another one is streams. What the dynamic tables will do, right? It will in dynamic tables you have to give some lag. Lag means you have to give some time. It will take the data. It will take the data and then it will do all transformation inside the dynamic tables. Inside dynamic tables, and then it will store the result in the target table. Entire process dynamic tables it will do. Okay, it will do the transformation as well as it will directly store in target table. If we are using streams, right, what will happen? It will perform only CDC. What it will do? It will perform CDC. After that, I have to use task is another object. In that, I will have SQL queries. What the task will do at a particular time, it will run these SQL queries. If I am running a SQL query, what we can say it is it's a
Transform.
transformation and finally load into the target table. Now I'm going to ask few questions to you guys. If I using dynamic tables, whether I need any task,
No, sir.
if I use that for performing CDC, whether I need task for dynamic tables,
No, sir.
no. For performing CDC and then doing some transformation. See, I made a blunder mistake, guys. For performing CDC and plus transformation, I can use dynamic tables directly. What I'll do it, I'll do the CDC and do transformation directly load in target table. If I want to do CDC plus transformation, streams will extract only do the CDC part, change data capture part, and then the task will trigger the SQL queries. It will do the transformation and finally load in target table. If you need to do CDC plus transformation, you need both streams as well as
Task, sir.
task. If you want to do CDC plus transformation in dynamic tables, whether you need task,
No, sir.
no.
Dynamic table.
Sandamal, no need of any task. Okay, good. Now I'm going to work in the both use case. Okay, as of now I'm focusing on dynamic tables. I'm going to focus later thing on streams. That's what they have mentioned here. Instead of managing transformation steps with tasks and scheduling. Okay, if you are using some other things, right, we have to use some tasks and then we have to schedule the SQL queries, then only will perform the transformation. Okay, now in the dynamic tables we have to have the declarative programming. Declarative programming means in the while creating dynamic tables you have to provide a SQL query. Sendamal, we are going to follow declarative programming while creating dynamic tables. Under one session, you have to provide the SQL query. That SQL query will do the transformation. Okay, that's what I'm saying is for dynamic tables, no need of any task. While creating dynamic tables itself, what I will do, I'll put the
Yes, full. Yes, yes, full.
SQL queries. Okay, that's why it's very popular. We have to follow the declarative programming approach. Declarative programming approach means while creating dynamic table itself, you have to define your SQL. That's your declarative SQL. Okay, and then no need to worry about the steps to achieve them. Okay, no need to worry about steps like what it's going to do. Whatever the SQL query is doing, right, that query will do the transformation. And then transparent orchestration. Orchestration means what happens from the source table, it will extract the delta and will do all transformation and finally load into the target table. This transparent orchestration, orchestration means the flow of data you can able to see. That is nothing but the transparent orchestration. You can able to easily create the pipelines using dynamic tables. Okay, and then you can form some linear chains to direct graph. Now you guys are get confused. What is the transparent orchestration? Now I'm going to draw one pic for you guys. Now I have one source table. source table. I have 1000 records. Now I am creating a dynamic table 1. dt1 means
Dynamic
dynamic
tables.
table 1.
Table 1.
In that I'm going to give lag. Lag is 5 seconds. And then I'm going to give the SQL query. And then I'm going to have one more dd2. What is dd2 stands for?
Dynamic table 2.
Dynamic table 2. I'm going to give the lag as 10 seconds. And then I'm going to use one more SQL query transformation. Now, what I'm doing is I'm creating a pipeline. Okay, I'm creating a pipeline like this. Pipeline means data flow will move from forward direction. Okay, that is nothing but pipeline. Now, what happens, right? Now I'm going to insert 2 records. Source table. Insert 2 records source table. Now, how many records will be there? Now, how many records will be in source table?
Sir, 1002, sir.
1002 records will be there. Okay, now I'm testing you guys. Okay, now just assume that in source table you have 0 records. I created a chain, okay, using dynamic tables 1 and dynamic table 2. I created a chain. Now what I'm going to do, right? I'm going to insert 5 records. Guys, listen carefully. Anand, I'm going to insert 5 records.
Yes, sir.
Now what happens, right? Once the 5 records got inserted, this dynamic table, it wait for 5 seconds. It will wait for 5 seconds and it will fetch the data from the source table. Now, dynamic table have how many records? dt1 will have how many records after 5 seconds? Source table having 5 records. After 5 seconds, it will get the data from source table. Now, dt1 has how many records?
5 records, sir.
5 records. Now, scenario number 2. If it is once again, okay, just assume that if it's once again, but I get 5 seconds here. Now, dt1 has how many records?
0 records.
0 records. After 5 seconds only, it fetch the data and put into the dynamic table 1. And then once the data comes into the dynamic table 1, it will do the transformation. What are the query given, right? SQL query, it will do the transformation. And then after performing all the transformation, what it will do, right? It will create a materialized table. Materialized table. Do you know what is materialized, guys? Anyone knows what is the meaning of materialized? Materialized means you are going to extract some results from some tables and then you're going to create a physical table because I'm extracting 5 records from table. That's a result. Okay, that's a result I'm putting into this table called materialized table. It's a physical table. Once you start querying in the materialized table, right, the query performance will be very faster. The query performance in materialized table will be very faster because materialized table have its own physical location. Okay, if you don't talk about materialized table means don't be blind. Okay, just what I'm saying is materialized table means you are joining 4 to 5 tables. That results will be collected and will be stored as a table. Now dynamic table is materialized table. Dynamic table 1 is materialized table. Now, okay, this part is completed. You're doing some transformations. You're doing some filter transformations, and then it stored the results in the table. Now, dt2 after 10 seconds, what will do? It will get the results from the dt1 dynamic table, and then once it gets the data from the dt1, it will do all transformations. Whatever the SQL query you have provided, and then finally it's going to create another
Materialized table.
materialized dynamic table. Materialized dynamic table it's going to create. Like this, you can create n number of chains. N number of chains like DT3. What DT3 stands for?
So dynamic table 3.
Dynamic tables. Okay, there are 3 and 4. Okay, like this you can create a number of chains. Now, Anand, it's look like a pipeline or what? It's look like a pipeline or what? Data
Yes,
pipeline.
sir. Pipeline only, sir.
It's looking at data pipeline. You are doing a complete orchestration. One data is flowing from another dynamic table one, or another dynamic table one is flowing to another DDT2. Like this, you are creating orchestration. The flow of data you are doing, that's called complete orchestration. Okay, that's what they're mentioning here is. It's a transparent orchestration. You can be able to see from where the data is flowing, like from DD1 to DD2 is flowing. It's a transparent one. Anyone can able to see by chaining the dynamic tables together. Because we are chaining, right? One chain is following the another chain, and then another chain is following another chain. We are chaining the tables together. And then third feature is nothing but I want to discuss with you guys is performance boost incremental processing. Incremental processing. Well, now third feature I'm going to discuss is performance boost with incremental processing. Now, if I insert 5 records, that 5 records is coming to DD1. Okay. Now, I'm going to add another 10 records. Just I'll ask a question to you guys. I want to ask Sendaman and Priya. If I insert first 5 records, after 5 seconds, how many records will be in DD1?
5 records, sir.
5 records. Now, scenario number 2. Next, I'm going to insert 10 records. Now, you have to say how many records will be in the dynamic table 1. In dynamic table 1, how many records will be there now? After 5 seconds. Guys, make it mute. I'm getting some external noise. After 5 seconds, how many records will be the DD1? Because initially I have 5 records. So
15,
stable,
sir.
right?
15.
15. I want to know the count, man. Exactly. Already I have 5 records. Okay. If 15, you were saying that again 15 records will come. 15 plus 5, 20 records will come, right? Your calculation is entirely wrong. Anyone? I want to give it a try. Anand saying that 15 records. 15 plus 5? 15 plus 5. 20 records. That's not the right approach. Okay, that won't work in the incremental processing. It works on the incremental processing approach. Okay, now what happened, right? Though you have 5 records, just we'll make it 5. We'll remove this one. Already we have 5 records. Now I'm inserting another 10 records. In source table, now I have 15 records, right? Already 5 records is there. If I add in 10 more records, I have 15 records. Now what will happen, guys? It will do the incremental processing. Incremental processing means whichever the new records were inserted, right? That thing alone we will extract because we are doing a CDC concept. Change data capture. Whichever records got updated or inserted or deleted, that records will be captured and then will be stored into this table. Now, how many records will come? Anyone? We are following CDC concept. Satish?
Sir, 10
We are
records.
10 records will come. 10 plus 15 records will be in the DT1. Now, in DT2, how many records will be there? After 10 seconds.
Sir, 15 records.
15 records will be there. That's the power of CDC. Change data capture. Okay, good. Now, that's what I'm saying. It's a performance boost with incremental processing. Okay, it won't do the full load. It will do the only delta load. Keep in mind, guys, change data capture will do only delta load. Okay, it won't do the full load. Full load means that 15 should come directly. Okay, but it will, with what are the changes happened while inserting or updating or deleting, that change alone will be captured. Good. Now that's a performance boost. Only we are doing incremental load. What happens, right? It will performance will be really good because we have only less data, right? If we are doing some delta, If we have only less data, that will be good. Network connectivity will be good, and you are able to transfer data very faster or one table to another table. And then every 5 seconds, what I'm doing here, every 5 seconds I'm refreshing the source table. Okay, every 5 seconds I keep on checking the source table. If there are any changes, I will take the delta load and put into the dynamic table 1. And then easy switching. Easy switching means if we have any batch table or physical table, you can convert the table into dynamic table very easily using alter dynamic table command. Sendamal, what I'm saying is you have one table, you want to convert dynamic table. What you can do? Alter dynamic table command you can use, and then you can change the physical table to dynamic table. The normal physical table will be batch table. Batch table means batch of records will be stored in one table, and then you can make a dynamic table using this command. And then while converting dynamic table, right, you have to set the lag. How much time of lag it should get refreshed. The data should get refreshed after 5 seconds, right? The data will be refreshed in the dynamic table 1. Okay, like this will happen. And then finally, like operationalization. Okay, and then in the snow site, right, like you can see, like you can manage how many records came. Okay, and then what's the performance, everything can be able to see in the snow site. This thing I going to cover tomorrow only, because today's session I'm not focusing on the snow site part, because we can able to monitor the dynamic tables, and then how much percent of records are copied, and then whether it's active or not, everything can able to see using this snow site. That is called operationalization. Okay, now I want to say about a few things. um, the most important feature in the dynamic table is the result query will be reflected within the specified lag time. Once the lag time completed, right, what are the result query from source table will be reflected, and then we'll do all transformation. Finally, the results will be generated. Okay, and then you no need of any separate target table, or no need for any custom code for data transformation. Now, Satish, for this dynamic tables, whether you need any custom code or user event functions, you need any user event functions or any custom code for dynamic tables, whether you need any custom code or user defined functions to do the transformation?
No, sir.
No. Okay, and then if you see that pipeline, right, there's no need of any target table. Okay, because every dynamic table will have the metalist table. No need of any target tables, nothing. You can keep it like this. What this thing is, we can do the complete elimination of the target tables. No need of target tables, because every dynamic table will acts like a target table, and then we can do all kind of data transformation regularly through a scheduled refreshes. If you give some refresh time, right, every 5 seconds you keep on refreshing the source table. If any update happens, suddenly we'll take the data using CDC concept. Okay, now good. Now next one is I'm going to show some more you guys. Yeah, how the dynamic table works. It's one of the important concepts, guys. How the dynamic table works. Now you can see in the left hand side there are two base tables we have. Base table can be any table. It can be staging table A, staging table B. Now what I'm doing is I'm writing some joins in my dynamic table A. The A and B, okay, A and B have, right. A is a dynamic table. Sorry, A is a base table. B is a base table. C is the dynamic table. Now in the dynamic table A, what I'm doing is I'm writing on SQL query to join these two base tables and doing some aggregation, and finally I'm getting the results in the dynamic table A itself. Now Sendamal, one person inserting 20 records in base table A, 50 records in base table B. I giving the lag of 5 seconds in dynamic table A. After 5 seconds, what will happen? I run my SQL query like I want to join the two tables. I'm going to do some windowing functions, aggregations, max, min, everything. What will do, right? After 5 seconds, it will take only the delta part. Delta means change data capture part. It will take only the new records and then it will apply the transformation and finally store the results in the dynamic table A. Got it? Now, go to dynamic table B. What the dynamic table do, right? Now, some people they're adding 30 records, table A. Some people adding 50 records in B. What it will do? In dynamic table C, you run one SQL query that is going to join, table A and B. You did some queries like some aggregations or grouping, something you did. That results will be stored in
Dynamic table C.
C. Now, you given some lag time. Okay, after some 2 seconds, what will happen, right? We're going to do some joins, and then what happens, right? It's going to do some transformation, going to do it, and it will see. Now, if you go to dynamic table B, right, what happens if any new records are updated or did happens in the table A and B, what happens? That results will be reflected in the table C. After the table results reflected in dynamic table C, what happens? These three tables will be joined, and finally I will get the results in the dynamic table B. Guys, got it?
This conference will now be recorded.
Yeah, guys, what I am saying is it will be an automated refresh process. Once any new record or update delete happens in the table A and B, what happens, right? Yeah, after some few lag time, the table A will get updated. Okay. After that, if you look at dynamic table B, right, what happens? They are taking the base table B as well as dynamic table C. Okay, if any update happens in this table, right, that will be reflected in dynamic table C, and then after this is updated, then you can able to see the updates in the dynamic table B, because you have to give the lag time, less lag time here, and then more lag time here. Okay, and then one guy asked me a few minutes back, a few days back, in order to reduce the cost, whether I want to what I want to do in the data tables, you have to choose a longer lag time. Like you can take like 5 hours, 6 hours. Yeah, if you are keep on refreshing every 5 seconds, right? What will happen? The charges will be more in Snowflake. If I giving the refresh time as 8 hours, 8 hours one it will refresh the data. If we are giving 1 minute or 5 minutes, right? Every 5 minutes it will keep on refresh the data. It will increase your cost. Reduce your cost, just increase your lag time. Okay, good. Now this is what they're trying to say is I want to say when to use dynamic tables, which scenarios you want to use dynamic tables. Okay, dynamic tables are best used no want to write any code, previous ETL, right? ETL scenarios, they will write some SQL queries to perform CDC, change data capture itself. They'll write some piece of code in dynamic tables. Whether you want write code for CDC, my question is, in ETL they'll write some SQL queries to get the CDC data, change data capture data. For dynamic tables, have you want to write any piece of code to get the change data capture data? I'm asking a question to you guys.
Sir, don't need, sir.
No need, because internally built-in features available. What happens, right? Once whenever the data comes into the base table, it will extract the delta. Okay, that's what I'm saying. Don't want to write code to track data dependencies and manage data refresh. Everything will be automatic in data tables. Automatic refresh will happen. Second point. Uh, okay. Um, In the dynamic tables, whether you want to use any task to run your transformations, in dynamic tables, whether you need any task to run your transformations,
Yes, sir.
in dynamic tables you need task, right? Sadesh is saying that in dynamic tables you need task to run your SQL queries.
Sir, sorry, sir. In task only, dynamic
See,
tables.
I'm asking that in dynamic tables you want to do some transformation. For running a transformation, you need task or not? Say yes or no.
Sir, no, sir.
No. For streams only, streams will extract the CDZ. And then for doing transformations, for running the SQL queries, you need task in streams, not in dynamic tables. And then third point, okay, um, okay, yeah, and then what we can do in dynamic tables, okay, you can materialize a result. Materialize means you can collect all the results from various tables, and then you can materialize results of a query of multiple base tables. That thing can do for the scenarios. If you want to materialize results, send them out. If you don't ask what materialization means, you have to say from various tables I'm collecting the results and putting in one table. That is called materialization. But in dynamic tables, what I'm doing is I have multiple base tables, staging tables. I'm collecting the results and materializing of the results from multiple base tables. Okay, for the kind of scenario, which table you have to prefer? You have to cut all the results from the tables and put into the one table. Now, which table you will prefer?
Sir,
You'll go for
dynamic table.
you will go for temp table or physical table or dynamic tables.
Sir, dynamic table.
Dynamic tables. Okay, that's the third point. Fourth point is for dynamic tables, whether you want to build any ETL pipeline. I'm asking guys for dynamic tables
No
whether
need.
you want to build an ETL pipeline.
No need, sir.
Okay, see, actually, it looks like a ETL pipeline. Okay, what are the building, right? What are the dynamic building, right? Look like ETL pipeline. Okay, that's what the saying is. If you want to build multiple tables to transform data, for example, DT1 will do one transformation. DT2, dynamic table 2 will do another transformation. DT3 will do another transformation. Like this, you can able to create an ETL pipeline using dynamic tables. Okay, that's the fourth point. And then the fifth point I can say is no need of any refresh schedule. No need of any refresh schedule is required in the dynamic tables. Automatic refresh will happen once the data is landed into the base tables. Okay, no need of any manual refresh schedules as well. Okay, no need of any task only will be able to schedule the schedule control will be there, but dynamic tables no need of any schedule control, automatically it will refresh. Okay, and then the last one is and then no need of any uh, unsupported dynamic query constructs such as stored procedures, okay, and then non-deterministic functions. It's not required, okay, because dynamic tables will handle everything. No need to create stored procedures. What in ETL they will do, right? They will do all the transformation logics in the stored procedures. They will call the stored procedure. If they call the stored procedure, what will happen, right? In the stored procedure, they will write all kind of transformation. The transformations will be done. But in dynamic tables, whether you want to use any stored procedures, Chandamal, in dynamic tables, whether you need any stored procedures, in
Sir,
dynamic
no need.
tables,
No need.
I'm asking Chandamal, in dynamic tables, whether we need any stored procedures or any functions required to do some full refresh or doing some kind of transformations, it's not required. Okay, but mostly in ETL, right, what they will do, they will write on store procedures. Inside store procedures, they will write all kind of transformation logics. Once they call the store procedure, right, they will do the transformation logics. Now in dynamic tables, no need of these things. Now what I'm going to do is I'm going to have one quick demo session. because we have n number of features available in dynamic tables. I don't want to show all this today. Tomorrow we'll discuss all these things. As of now, we're going to have a quick demo. The use case I'm going to show today is change data capture using Snowflake dynamic tables. How to do the CDC concept using Snowflake dynamic tables. Just come one by one. Now, I already discussed about this dynamic table, right? I want to give you a quick glimpse. Dynamic table, what will do, right? It will materialize the result of query that you specify. Okay, what happens, right? It will take the data from the staging table, and whatever the query given, right? For that query, it will do the transformation. That results will be collected, and finally it will create a materialized table in a dynamic. Sorry, materialized results in a dynamic table. And then in dynamic table, what happened, right? It will track the changes in the query data and specify the refresh the meta result incrementally through an automated process. What they're trying to say is it will look at the source table based on your lag time, right? You will keep on refreshing source table. If anything happened in the source table due to some DML operations, it will take the data. Based on the data, it will do the all kind of transformations and finally will load into the dynamic tables. It's one of the automated process. As well as they are doing only the incremental load. They are not doing any full load. Whatever data got changed, they are taking one incremental data and then they are trying to put in dynamic tables in a materialized way. Okay. Now, I'm going to directly go into syntax. For creating dynamic tables, what is syntax? What is syntax?
Create or replace.
Create or
Create a
replace
dynamic
dynamic
table,
table.
table name you have to provide, and target lag you have to provide. Target lag you have to provide in terms of seconds or minutes or hours or days. In terms of you have to provide it, and then there is one more option we have called downstream. Okay, downstream means, now I'll give a hint to you guys. If dt1, sorry, dt2 is dependent on dt1, right? dt2 is dependent on which one? dt2 depend on
DT1, sir.
dt1. dt3 depend on
DT2,
2. dt4 depend on
DT3.
3. Now what I going to do is, instead of giving some seconds, minutes, hours, days, I going to give laggers, laggers, laggers
Downstream.
downstream. Now for dt1, who is the downstream? For dt1, who is the downstream?
DT2, sir.
dt2. Now what happens, right? In the dt2, I given some. I going to remove this lag. Okay, don't get confused, guys. I going to remove the lag for dt1, and what happens, right? dt2, I have given 10 seconds. After 10 seconds, it will take the data from the dt1. It takes the data from the dt1, but dt1 I kept it downstream, right? If dt2 pushes the dt1, then only dt1 will get the data from the source. So now it's clear. dt1 lag given downstream. Okay, dt2 given 10 seconds. After 10 seconds, dt2 will say to dt1, hey, I need the data, just give the CDC to me. Then DT1 what will do, right? As per the DT2 request, DT1 will go to the staging table and will get the incremental data and put into DT1 and will do all transformations and give the results. After the DT will get the data. As per the DT2 request, it will fetch the CDC from the source table. Got it? That is nothing but
Downstream, sir.
downstream. Now, guys, I'm giving 2 minutes of time for you. Just look at syntax. You have to listen very carefully. You have to target lag. You can provide seconds or minutes, hours, days. Now, if you want to reduce the cost, which lag you will prefer? If you want to reduce the cost, Your business saying like that, my staging table will refresh every 2 days. Every 2 days it will get refresh. Now what is the target lag you will specify?
Sir, days, sir.
Days. Yeah, you will mention 2 days. What you have to mention? Two
2 days.
number you have to put
Yes.
two, and then you have to put days. Okay, 2 days you have to specify, because you see, if you are choosing some higher lag, right, what will happen? The cost will reduce. If you are keeping some minutes, right, every 5 minutes will keep on refreshing the tables, and then your cost will be more. Okay, and then right, downstream means as per any of the downstream request, it will refresh the source table and get the delta records, and then do the transformations. Okay, and then warehouse equal to, you have to write a warehouse name as you have to provide a query. What are the transformation logics you written, right? That query you have to provide it here. So now it's clear. If it's clear, I'll go to next session. It's clear for you, Sundamal? If it's clear, I'll move to the next session.
Yes.
Yeah, it's clear, right? Good. Now look at the pictorial view. Now T1 is the which table it is. What is T1 stands for?
Sir,
It's
I
a
think so.
it's a staging table or a kind of base table. Okay, DT1 stands for
Sir, dynamic table one.
Dynamic table.
dynamic table 1, DT dynamic table 2. What happens, right? Yeah, it's automatic refresh is happening. See, do the automatic refresh. It will take the source table and we get a delta. Delta means it's incremental record only. Okay, good. Now see, I explained all these things to you guys. Directly going for a demo. Okay, I'm not going to use this demo. Okay, directly going to use some other demo. Just I will go for a snow site, guys. Just do one thing. Go to worksheets and create a new worksheet. Just give some name called dynamic tables. Dynamic tables, and then choose some database name. If database name is not there, create database. If not exist, give the database name. Okay, just give some. It's called table name is. What's the concept name, guys? I want to see the concept name, that is continuous data pipelines, right? Continuous or can data transformation. Okay, you can give the database name as data transformation. Sorry guys, transformation. Okay, okay, now use data okay. Now everything done. You can see in the topmost right. Default, go to public schema. Don't use schema. Just create a new schema. Create schema, and then we make in that transformation, right? Yeah. Data underscore tx underscore schema. Okay. That transformation schema. Yeah. Now just use schema name. Okay, good. Everything done. Okay. Now you have to choose your warehouse. The warehouse I have default warehouse, compute underscore WH warehouse. Okay. Otherwise, you can create some other warehouse to do the complex transformation very faster. You can choose some X large. Okay, you can choose it, and then you can able to achieve the results very faster. Good, guys. Okay, guys. Now, what I'm going to do is this is a quick demo I want to show to you guys. Just what I'm going to do is, okay, I'll do one thing. First, I create a source table. Guys, it's clear for you. If I want to get the DDL, what's the statement? If I want to get the DDL, what's the statement?
Sir, get detail.
Get DDL, right? The function. What I provide? Object type I want to provide. Just give table and then provide the namespace. Have the you can see the DDL, right? This is the DDL I created. One is ID, name, value, created at it's a timestamp data type. Now I go into insert few records. Anand, if you have any doubts, you can ask now.
No, sir.
Okay, now you can see inserted 3 records. You can see the 3 records. This is my source table. Source table means it's a staging
Staging layer.
table. Okay. Now you can see how many records are there. Sandmara Stranzo, how many records we have? Who said 2 records? Sandamar? How many records we have?
3 records, sir.
3 records. I'm asking Sandamar. He's not in the call. Sridhar Priya, how many records we have?
3 records, sir.
3 records. Good. Now, next one is what I'm going to do is I'm going to create a dynamic table. Okay. See, if you want to create a dynamic table, right, you have to follow the syntax. I will show syntax, guys. Just this is the syntax you have to follow. Okay. You can take the syntax from here, or you can take from the official documentation. Okay. Just I will show here where to get the syntax, guys. Just to go here. Yeah. Tables is there, right? Best practice you can go. Sorry. Yeah, I think we have syntax. Yeah, working dynamic tables, right? Yeah. You can able to see create dynamic tables. You can refer this official documentation. You can see, right? This is the example again for you. Okay, from this example you can learn. Now the same thing I am following here. What I am following here is, if you see syntax, you have to provide the dynamic table name, target lag you have to provide, warehouse you have to provide. Okay. Now, good. The same thing I follow here. Create a representative table. I given the dynamic table name table 1. Target lag how much time I given? For demo purpose I given 1 minute, because like I can't wait for 5 minutes, right? That's why I given 1 minute. Okay. And then otherwise I will do one thing for you guys. I'll keep 2 minutes. What is the warehouse I'm using? What is the warehouse I'm using?
Sir,
The computer underscore W.
Computer. Who said computer? Who said computer? It's a compute engine. Computer underscore WH. publish as a warehouse. Now give the warehouse name as commit underscore wh and then give as and then write your SQL queries. Complex SQL queries also you can write. Okay, I'm going to show this thing, guys. As of now, I'm not doing any transformation. Okay, I'm not doing any transformation. If you want to do some transformation, right, you can do it. Where what I can do is value, right? Value greater than 30. What transformation it is? What transformation it is? What transformation it is? I don't know, some SQL query. I do some transformation. What transformation it is?
Sir, where class, sir?
Hey, it's a filter transformation, man. It's a filter
Calculate
transformation. It's a filter
three
transformation.
records.
That's what I'm saying here. Now, what I'm going to do is, I'm going to get a dynamic table. Just do one thing, guys. Just copy as it is. You're saying where again. It's a filter transformation. Just create a dynamic table. If I put greater than 30, right, what will happen? First, this dynamic table, what will happen, right? It will refresh that after 2 minutes, it will refresh and get that data from the source table, and then it will do all the transformations and then store the results, material results in the dynamic table. Just create the dynamic table. Now dynamic table is created. If you query the dynamic table, whether you can see any results, whether if you query the dynamic table, you can see any results.
No, sir.
I'm not able to see any results. Why? Why am I not getting any results? Guys, I'm asking why I'm not
Sir,
getting any results.
sir, lag time is 2 minutes, sir.
Lag time is 2 minutes. That's what my question is. Lag time is 2 minutes. After 2 minutes, you can able to see. It will refresh the source table and get the results. Guys, wait for 2 minutes. After that, you can see the results. Yeah, we have to wait. That's why I given for 1 minute previously. You want to see the lag, right? It's not giving any results. I think it's not crossed 2 minutes. I think it's less than 1 minute, I guess. That's why it's showing query is not producing results. I think it's running, guys. No, it's not giving any results for us. 7 minutes crossed 2 minutes, right? Make it mute, guys. And it's crossed 2 minutes or less than 2 minutes.
No, sir. Less than 2 minutes only, sir.
Yeah, I think it's 7:23. Comes means I think it will run. Let's see, guys. No. Yeah, we have to wait for another 40 seconds. I think it should cross 22 minutes. Yeah, 7:23 came. I think it's not giving any results for us. Wait for 10 more seconds, guys. Let's see the results. It's not giving any results, guys. We'll do one thing. Guys, make it mute.
This conference will now be recorded.
Guys, I'm not getting the results because I made a blunder mistake. Okay, the first mistake I did is the target lag. As per the syntax, I have to give minutes. Okay, but here I given, I miss a yes. That's the one mistake. And then in the source data, what I'm doing is I have 10, 20, 30. But here I having greater than 30. It's taking all the data from source table and applying this condition. There is a transformation, filter transformation. Okay, that's why I'm not able to say any results in my table. Now what I'm going to do is I'm going to do one transformation. I'm not going to apply any transformation. Okay, I'm just going to remove this filters as of now because I'm going to put the chained data tables. Okay, now after changing all these things, just create my data tables. Now the data tables get created. Now you can query the table. It has to get the results. It's getting the results, right? Okay, good. Now you can see Alice, Bob, Charlie, everything getting value 10, 20, 30 are getting, and getting the credit at data also getting. Now, good. Now what I'm going to do, right? I got the results in the data table 1. Okay, I'm going to create one more data table. It's going to form like a chain data table. Okay, just do one thing, guys. Create another data table. In the data table, what I'm going to do is I'm going to filter value greater than 30. It's a filter transformation. The remaining syntax has to be as it is, and then the table I want to use. 1 minute, guys. It's not a table actually. I want to show this one. This is a dynamic table 2. In that target lag is going to keep something 1 minute, right? I'm going to keep it 1 minute, and then warehouse is compute WH, and then I'm using this query, and then I'm doing the filter transformation. The table name you have to supply is dynamic table 1. Okay, be clear, guys. Just copy the statement and then put it here. Previously I given the lag. What lag I given? 2 minutes I given. You have to give at least for this one. How much lag you have to give? You can give 3 minutes. 3 minutes lag you can give, and then you have to supply the dynamic table 1 here. Sendamal and Satish, don't put source table here because it's a chained dynamic table. Chained means from this dynamic table I'm getting the results. Just copy the dynamic table and putting the results here. Okay, just create a dynamic table 2. Okay, and then what you can do, right, in the meantime, if you refresh, right, in the database, in the schema, you can see tables and dynamic tables. Go dynamic tables, you can see number of rows, what the size, what the cluster key you are using, what's the lag time. Refresh mode is, what's the refresh mode?
Sir, incremental.
Incremental, it's a delta. Okay, incremental delta. You are getting the delta records, and then you're doing like this. Now if you query the dynamic table, right, how many records will be there?
2 records.
Only 2 records because the value I putting greater than 15. Okay, I'll get 2 records. This is how they are doing some transformation, continuous data transformation. Continuous data transformation. You're seeing, right? I'm not getting the first record because if the value is 10, right, I'm putting greater than 15. The filter transformation I'm doing 20, 30. I'm getting the records. This is how we can do. Now I want to show few things to guys, like I want to do some insert updates. In my source table, I going to insert few records, 25 and 35. 25 and 35. You can Sandra, I said what I can do. You can do inserts, updates, deletes, all kind of things will be done. But I'm doing source table, guys. Be clear. I'm not doing dynamic tables. The staging table, I'm doing all these things. I insert two records. Done. Now what I'm going to do is I'm going to query the dynamic table one. In dynamic table one, how many records will be there?
For 3
You guys have
records.
to say. Dynamic table is saying again 3 records. How, man? How it's possible? Satish, this is how I teach to you. Already we have 3 records in the source table. That 3 records will go to the dynamic table 3, dynamic table 1. Now dynamic table have 3 records. I'm adding additional 2 records. You saying again 3. How it's possible? Now dynamic table 1, how many records will be there?
Sir,
For
5
5
records.
5 records will be there, man, because it's taking the delta. It will take the 4 and 5 delta, and then, yeah, once again, yeah, I think it's not refreshed, guys. Once again, I'm not getting David and Evie. It will take a time, I guess. Guys, wait a minute, hold a minute. It's not refreshing for me. It's showing the old records for me. I inserted on the source table, right? Whether I inserted or not, that's my question. I think I didn't insert the table. Okay, just insert it. Now 2 records were inserted, right? I think now you should have the 5 records. Satish, these 2 records will be new records that will be captured in the CDC. That 2 records will come to dynamic table 1.
Okay, sir.
Yeah, I think I insert twice, man, because we do some I insert twice, right? That's why getting twice. Got it?
Yes,
See,
sir. Yes.
mistakenly I inserted 4 and 5. Again, I inserted 4 and 5. Don't get confused, guys. Twice I inserted. Sendamal? Twice I have inserted. Don't get confused. Because mistakenly I inserted another time. Because I given the lag as 1 minute, right? In the 1 minute, we'll get the records. That's why getting 4 and 5 twice. Sridhar Priya. Anand? I getting 4 and 5 twice because of insert twice.
Yes, sir.
Good.
In the
Yes,
first
sir.
dynamic table, we are given 2 minutes, sir. So,
Yeah. 2 minutes, right? That's why there's a lag is there. That's why you're taking like 2 records came. Good. Now, if I query the dynamic table 2, how many records will be there? You guys have to say.
sir, 4
Consider this
records.
record. Certain number, how many records will be there? Because I given value greater than 15. Value greater than 15. How many records will be there? He's saying 4. How come 4 will come? Anyone?
Sir, 6 records, sir. Sorry.
See, Satish, without looking at the translation logic, filter translation logic is saying anything, everything. Because I given the translation logics here, logic is greater than 15. Let's see. How many records are getting, Satish?
6 records, sir.
6
Six
records.
records. 6 records. Anand won't answer for anything, but if a chorus answer means Anand will answer. He has to get 6 records. This is how you can do the chain dynamic tables. Okay, guys, good. Everything is good. Tomorrow I'll come with complex SQL queries, and then I want to perform the dynamic SQL dynamic tables. Okay. Before that, I want to show a few things, guys. How to show the dynamic tables. How to show the dynamic tables. You can use show dynamic tables. show dynamic tables. You can see how many tables are there. When got created, what is the dynamic table name, what is the database name, schema name, cluster by, there is no cluster by, and how many rows are there, and how many bytes are there, who is the owner, and what is the target lag we have provided to the dynamic table, what is the refresh mode, and then a refresh mode reason I'm not provided anything. I provided the warehouse, and then what is the command I given to create the dynamic tables, and then automated clustering I made it off, scheduling state I made it active. Okay, is clonable. Yeah, this dynamic tables is clonable if you want to make it true. Okay, and then you can see the data timestamp as well. Good. Now this is a one way to show the dynamic tables. The another way I can show is I'm going to use the regular expressions using like operator. I'm going to use the regular expressions using like operator. You can use percentage in the back. Okay, that will give the what are the dynamic tables we have. It will start from dynamic table underscore. Whichever name starts with dynamic table underscore, it will give those tables. Okay, and the next one is third way to see the tables. You have to provide your table name. My table name is dynamic table 1 and 2, right? 1 and 2. I given dynamic table underscore in schema. Which schema I have? What is my schema name? Anyone? What is the schema name?
Sir,
Yes.
Transformation, and
underscore
then data underscore
data underscore
tx schema.
ts t
Tx means it's a transaction schema. Okay. Now you can able to see the dynamic tables. This is the third way. The fourth way I can show to you is you can use starts with. Show dynamic table starts with the, you can give the table name starting. What's your table name starting?
dynamic tables, dynamic underscore.
Dynamic, right? That's why you're giving starts with. It will start with dynamic, right? Then we'll give the dynamic table names. This is how we can able to see the tables. Okay, guys, these are the informations. It will be created. You can see the informations. Okay, good. Guys, I'm going to close session right now. Tomorrow we're going to discuss with again same dynamic tables with some different complex logics, and then I'm going to show the snow sites, and then I'm going to show them some information schema. All these things we're going to see tomorrow. These are the basic stuffs I shown today.